These are some problems that will be on your unit exam, Part B, number 4. Now, on these problems, I did 4 of them. What might change on your problem is the amounts. So, you know, instead of a 300-foot building casting a shadow, I might have put 100-foot building, or I might have put a 25 feet long. So, just for the different versions. So, if you know the process, here you're good. So, here's your one of the versions that might have this problem with different numbers. So don't forget, and a lot of students were asking me this, what is the angle of elevation? Remember, so if the sun is here, here's the sun, and you're down here, alright, the line of sight is the diagonal. So angle of elevation is below that line. So what we're looking for is alpha. I'm going to call it alpha, the angle of the sun. So all we're trying to find here is alpha. So what we have, if we have alpha, we have opposite over adjacent. So that would be tangent. So tan of alpha equals opposite, which is 300 feet. Let me put feet here. Over 50 degrees, or 50 feet. This is 50 feet. Alright, so then we're going to find alpha. So alpha equals tan inverse of 6 feet. As you reduce this, you get 6. So alpha is approximately 80.5 degrees. And that is the angle of the elevation of the sun. Okay? Another one. You've seen this before. A ship offshore from a vertical cliff of 100 feet in height. Again, on your unit exam, these two numbers here might change. You have your angle of elevation is right here. It's the right triangle. We're just going to, this is the line of sight. It's hard to write that with this iPad thing, but line of sight is what that says. So we're going to let x equal the distance from the ship to the shore. It's very similar to our other problem. So we're also going to use tan. So we have tan of 25 equals 100 feet over x. So x equals 100 feet divided by tan of 25. I do recommend that you have a calculator when you're looking at this, because I already did the calculator and I'm looking at my work to save time with the video. And that's going to be approximately 214.45 feet. This is the one that was on your quiz. This is the one that was on your quiz, and a lot of you all use cosine for some reason. So keep in mind this is tan. You can draw the picture differently, but you still would use tan because you have opposite over adjacent. Okay. Another problem, same thing. The problem you might get will have different numbers here, but basically we are looking for the distance from, here's your angle of elevation, this is your angle of elevation, this is your line of sight, and they're looking from the distance from the ship to the base of the statue. This would be your Eiffel Tower. Not Eiffel Tower, but the Statue of Liberty. So, what we're going to do is just use tan again. It's tan of 20 degrees equals 305 feet. Erase that. Over x. So x equals 305 feet over tan of 20. Since we're using a calculator, we're getting approximate values. and that's going to equal, let's see, 37.98 feet. Apparently, this is not proportional when I drew it, but that's okay. So our answer for x, this length here, is the distance to the shore. Okay. Alright. Another one you might have is, for your number 4, is this one. You have 2 sidings. This one's a little harder. The only thing that might change are these numbers here on your version. So what I suggest on all of these, we're looking for height, but I suggest on all of these is to look at my videos, replace different numbers, these numbers, so you can get more practice, so you do well on your unit exam. So the first thing we're going to do is we're going to let x equal, let's see, we're going to let, we're trying to find x here. So this is the distance from here to here, and we have to find the height of the building. So we have 2 unknowns in this case. So the first thing I'm going to do is I'm going to look at this triangle here. So this one right here, it's not that hard, it's just extra steps. We're going to look and see how to define x. So tan of 40 equals height over x. And I want to know what x is, and we'll see in a minute why. So x equals h, the height over tan of 40 degrees. Alright, so that's that part. Now for the 32 degrees, we're going to use tan of 32 degrees, this is degrees, equals height over 50 plus x, because it's this whole length here. So you're going to put 50 plus x, and we're going to solve for height. So height equals 50 plus x. I'm going to change that to x plus 50, just for aesthetic reasons. Alright, so I'm going to change that to x plus 50 times tan of 32. Now, you might want to get this down and get out your calculator, because I'm going to have to go to a new page on this. What we're going to do before I go to the next page is I'm going to replace this x with this, because I'm going to use substitution. And I'm also going to find out what tan of 40 is, and also what tan of 32 is here on the next page. So it's going to look different. I'm going to be changing this. Let me go to green. I'm going to be evaluating this with the calculator, substituting this for x here, and I'm going to evaluate this with the calculator. So it's going to look a little different. Alright, so we're going to get h, oops, come on, h equals, oh, why isn't this working? H equals my x that I had on the previous page, which is h over tan of 40. And tan of 40 is 0. Why isn't this working? 8.391. Alright? And then plus we had our 50. That's the part in the parentheses I had. So this was my x right here. This was my x. I substituted for x. Now, my tan of 32, I went ahead and evaluated that with the calculator, and that is 0.6249. Now, all I'm going to do is use the calculator and distribute. I'm going to distribute here and clean this up. And I get h equals 0.7447 times h plus 31.245. Alright, all I did was distribute this with this,
and came up with these two values. Now I'm going to solve for h because that's what we're looking for. I subtract 0.7447 h from both sides. Remember, this is 1 times h. So that cancels, and I get 0.2553h equals 31.245. I divide both sides by right here I'm dividing by 0.2553, and I get h is approximately 122.37 feet. Again, on all four of these problems, you need to look at them. You'll have one of these versions, but with different numbers, so you need to go through and practice with different numbers. So that's what we found h here.